Simplify. 1 over x squared minus 4 minus 5 over x squared minus 4x plus 4. So we have two fractions here. These are called rationals. If you have a fraction that is a polynomial divided by a polynomial, that is a rational. So we have two rationals. So we're going to combine them. Okay, so they're fractions, right? So we know that if we have a over b minus c over d, we can't combine them the way they're written like that. First thing we must do is we must build a common denominator. So the way you would do this was you would find the least common multiple of the denominators. LCM stands for least common multiple of the denominators. You're going to use that to build your common denominator. So for this example, the least common multiple is b times d. So this one needs a d on the bottom, which means we have to put a d on top. Minus c over d. This one needs a b on the bottom, which means we have to put a b on top. And you would build a common denominator like that. So ours is a little more complicated because we have these polynomials. We're going to try to factor them so we can see them as a product. Okay, so we're going to look at each denominator and we're going to try to factor. Okay, so we have x squared minus 4. The first question we always ask is, can we factor something out of both terms? Is there something that's a greatest common factor? In this case, no, there's not. Okay, so the next question is, how many terms does this have? Well, it has 2. Okay, so well, is there a minus sign in the middle since it has 2 terms? Yeah, there is. Okay, well, maybe this is a difference of 2 squares. Difference of 2 squares looks like a squared minus b squared, and that factors to a minus b times a plus b. So the things that really kind of clue you in, there's 2 terms and a minus sign. And we say, what do we square to get the first term? Well, we can square an x, so that's what goes in the front. And then we say, well, what do we square? What value do we square to get the back term of 4? Well, 2 times 2 is 4. So we put that here. Now there's a minus sign in the middle. Remember, when we were to expand this out, we're going to FOIL. Okay, so we say, well, what combination of signs here, when I multiply together, gives me a minus? Well, the only way you're going to get a minus is if the signs are different. Because if you had a negative times a negative, that gives you a positive. Or if you had a positive times a positive, that gives you a positive. So the only way we're going to have a product of the last 2 numbers, the L, first, outer, inner, last, the last, that is a minus, is if these signs in here are different. Okay, so that's the factorization of the first denominator. Let's look at the second one. X squared minus 4x plus 4. Okay, spoiler alert. This one is one of our special products, but let's pretend you don't notice that. How would you factor it? Well, you look for factors. There's a leading 1 right here, right? Leading coefficient of x squared is 1. You look for factors of 1. You look for factors of the last value, the constant, 4. So 1 and 4, 2 and 2. And we can look for a combination. I want to point out a couple of things. The last sign is positive. Positive. It tells us a couple of things. It tells us, first off, that signs in the parentheses when we factor are going to be the same. Not only are they the same, but we're going to use the middle sign. So in our example here, they're both going to be minuses because the middle sign is negative. Okay. They also tell us the last sign is positive, that we will add to get the middle term. Since the lead coefficient is 1, this is actually a little bit easier to factor. You factor this. You put your x in the front because x times x is x squared. And then you say, okay, well, the signs have to be the same, and I'm going to use the middle sign. So I'm going to do them in green. Middle sign. So if I add these or combine these, do I get negative 4? Well, negative 1 plus negative 4, that's negative 5. So we see it's not that one. And look at the next one. Negative 2 with another negative 2. So negative 2 plus negative 2, we get a negative 4. We're going to use this one. So if your lead coefficient is 1, you can just put these guys in the back. Or you could do it by grouping, which is also called the AC method. So if you look at x squared minus 4x plus 4, we see that a is 1. Remember, a is the coefficient of x squared because you have a x squared plus bx plus c. So a is a coefficient of x squared, b is the coefficient of x, so b is -4, and c is your constant. So if you're looking for the AC method, we are going to multiply a times c. So a times c, that's 1 times 4, which is 4. And then we factor the 4. 1 and 4, 2 and 2. And as we said before, the last sign is positive. We're going to use the same sign, the middle sign, the negative, and then we're going to add. So which of these, when I put a negative in front, again, gives me a -4? I'm going to use this one. The difference with this method is I'm actually going to build the 4 terms and show you what they are. X squared minus 2x minus 2x plus 4. What we've done is replaced this middle term, -4x, with this sum. And that comes from the coefficients, the -2 and the -2. Then we're going to factor by grouping. We're going to group the first 2 together, and then we group the back 2 together. We're going to try to factor the first 2. What do x squared minus 2x have in common? They both have an x. That is the greatest common factor. And then we have x minus 2 left over. Looking at the back 2 terms, -2x plus 4, we're going to find the greatest common factor there. So again, if you thought it was a plus 2, you would write plus 2. Then you'd say 2 times what gives me -2x. You'd have a -x. And 2 times what gives me +4. You would do plus 2. Well, the problem with that is we'd like it to match this one. Okay, so you say, well, they don't match. The signs are all opposite. So it would be helpful, instead of factoring out a +2, I factored out a -2. So -2 times what gives me -2x? Well, that's x. And then -2 times what gives me +4, -2. So they both have an x minus 2 in common. I'm going to highlight it so you can see this one, right? So I can rewrite that. And then I can read off the rest. What I mean by that is, here's an x minus 2. Okay, so that's how we factor that one. Get the same thing as we did before, right? So now let's rewrite this in factored form. So we have 1 over x minus 2 times x plus 2, that's the new denominator, minus 5 over x minus 2 times x minus 2. Now we're going to find the least common multiple of the denominators. LCM is least common multiple of our denominators. Okay, so there's lots of ways to do this. I have taught math a whole lot, many years, and I found this is the way that makes the most sense to the most students. The first thing you do is you write down all of the factors in the first denominator. So x minus 2 times x plus 2. And I'm going to go ahead and do some highlighting. So I've written down this one, and I've written down this one. Okay, so that's what I have right here. And then we say, okay, well, looking at the second denominator, have I already written some of those down? Well, yeah, there was an x minus 2 already. So looking at the second denominator, is there anything I have not already written down? Yeah, I haven't written down this guy, right? They're the same, but this one appears twice. So now I also need to write down x minus 2 because I have to account that it was a double factor. It appeared twice. So this is the least common multiple of those denominators. Like I'm building a common denominator. That's what we talked about earlier. So I want the denominator of each one of those to now have those 3 factors. So this is the least common multiple, or my common denominator. So I had 1 over x minus 2 times x plus 2. It's missing a piece. I need the new denominator to also include x minus 2. However, I know that I have to multiply by the number 1, right? Which means I have to multiply by something over itself. So if I include x minus 2 in the denominator, I better put it in the numerator. Do the same thing with the second piece. I have -5, and the denominator here was x minus 2 times x minus 2. I am missing a piece, so I have x minus 2 and x minus 2. This is the piece I'm missing right now. So I need an x plus 2 in the denominator, but if I put it in the denominator, I have to put it in the numerator. That way I'm multiplying by the number 1. Okay. Now notice, the denominators are all the same. They may look different, but we have a commutative property which says A times B is the same as B times A. So A times B times C is the same as C times B times A, or A times C times B. I could do lots of different combinations. As long as these three factors are in the denominator of both, it doesn't really matter what order they're in if they're multiple. Okay, so the denominators are the same. So again, we have a rule that says if you have A over B minus C over B, if they have the same denominator, rewrite that denominator and combine the numerators. So we end up with x minus 2 times x minus 2 times x plus 2 times x minus 2 minus 5x plus 10. I'm distributing this over x minus 2 times x minus 2 times x plus 2. Okay, they have the same denominator, so I'm going to write one big vinculum. I'm going to put that denominator. It doesn't really matter which order you choose to write them in. I'm just writing them in the same as the first. So this is x minus 2 minus the stuff in the numerator of the back one with parentheses. I'm subtracting the whole thing. If I had dropped the parentheses, I would have x minus 2 minus 5x, but the sign of the back one doesn't change. I'm only subtracting the front. I know I'm subtracting both of them. So again, I'm going to distribute this sign. So we're going to get x minus 2 minus 5x minus 10 over x minus 2 times x plus 2 times x minus 2. And then we're going to combine like terms in my numerator. I'm going to rewrite the denominator. And we combine the x's. So you see we have an x and a negative 5x, which is negative 4x. And then we have a negative 2 and a negative 10. So that turns into negative 12. And if you wanted to factor the numerator, you could. It's not required. You could factor out a negative 4. Negative 4 times what gives me negative 4x? That's x. Negative 4 times what gives me negative 12? That's a plus 3. And the reason we do this sometimes is to see if you have factors in the numerator and denominator that are the same. So each of these are correct. You really could write either one. If you wanted to, you could also write this as negative 4x minus 12. Your denominator, you could have put the terms that were the same together and squared them like this. So any of these three are correct. X minus 2 quantity squared times x plus 2 is another way to write the denominator, because notice I have two terms that are x minus 2. Okay.